Today we are going to talk about the functional group isomers. So what actually the functional group isomers are? As you can see, the functional group isomers are when different functional group or chemical properties, they have different functional group and chemical properties are different. A chemical property is different because functional group, how it is defined as, functional group are defined as, it is basis on defined as they have a different chemical property. The functionality of the group is different. Okay, the term functional groups comes from where the functions function of that particular hydrocarbon is different, but molecular formula must be same. Then they are called the functional group isomers. So let's look the example. First, alcohols and ethers both could be, not always necessary, and the molecular formula must be same. Both could be the functional isomers. If we take the example like CH3, CH2, OH, this is alcohol, and we have CH3, CH3. This is our ether. So alcohol and ether both are functional group isomers. Okay, like you have, if you could take this particularly ether and this alcohol, so this is also alcohol. Okay, so ether and alcohol both molecular formula is same and functional group is different, so these are known as functional group isomers. Second, we talk about is alcohols and phenols. So what is alcohol and phenols? First of all, we're gonna write that this is our phenol. This is our phenol. And whenever a benzene ring, let me correct it. This is phenol. So whenever a benzene ring is directly attached to the hydroxyl group, OH group, that is known as phenol. But alcohol, if we write this as alcohol, CH2OH. Okay, this is alcohol. So these are the functional group isomers. If we take the another example, we have phenol. This is phenol and this is ether. And phenol and ether, since alcohol and ether both are the functional isomers, so phenol and ether could also be the functional isomer. This is important, since alcohol and ether both are functional isomers, so phenol and ether could also be the functional group isomers. Next, we're gonna talk about amines. Now, this is a very important point. That 1 degree, 2 degree, 3 degree amines together are the functional isomer. They are not a chain isomer, a position isomer. They are the function group isomer. Regarding the molecular formula, must be same. So, if you talk about amines, so if you write CH3, CH2, and CH2, then NHN. This is 1 degree amine, or we can say this primary amine. Next, we have CH3, CH2, NH, and CH3. We have 2 degree secondary amine, and we have N, CH3, and CH3, and CH3 with their 3 degree amine. Okay, so these are the functional group isomer. These are the functional group isomer. Remember, if we take the another example, N, then CH3, then we have NH, then CH3. These are also, this is 3 degree amine and this is 2 degree amine. So both are the functional group isomers. These also all the functional group isomers. They are not again other type of isomer. This we regard as a functional group isomer. Next is carboxylic acid and ether. Okay, these are the carboxylic acid and ether. So first we have CH3 or C double bond O OH. This is acid, and this is let me correct it. This is not ether. This is esters. Carboxylic acid and esters. So this is acid and this is ester. So this is acid and this is ester. So these are the functional isomer. Another example we could take. This is an acid and this is the functional isomer of it as a ester. Okay. Different. One more are amide. So amide is similar like amines, 1 degree, 2 degree, 3 degree amides together are functional group isomers. Okay. So amide, if we talk about its examples, CH3 or CH2, then CH2, C double bond O, N, H, then H. Okay, this is 1 degree amide. Another amide is CH3 or CH2, C double bond O, N, H, then CH3. This is 2 degree amide. And CH3 C double bond O, N, CH3 and CH3. This is 3 degree amide. 1 degree amide, 2 degree amide, and 3 degree amide. One more is, if we take one more example, this is like C double bond O, N, H, then H. This is like C double bond O, N, H, then CH3. Okay, these together are also the, this is 1 degree amide and this is 2 degree amide. The molecular formula must be same. This is the main important condition. Molecular formula must be same. Next we have an aldehyde and ketone. Aldehyde CH3, C double bond O or CH3. This is our ketone. And with the similar molecular formula, we could have another aldehyde. So these are the pairs. Okay, these pairs we have to keep in mind. So according to this pair, we could form the, we could relate that they are the functional group isomer. Another is aldehyde CH3, then CH2, and C double bond O H. This is aldehyde. Next is cyanide and isocyanide. Cyanide and isocyanide. Now, cyanide and isocyanide we have. This is our CN. This is our NC. This is called isocyanide. The N is forming a, how the or 4 bond of carbon are fulfilled because of one coordinate bond of nitrogen with carbon. Another example we could take, right, this one example of previous examples. Is it a functional group isomer? So both are ketones, so this is not a functional group isomer. If we take one more example like cyanide and isocyanide, this is cyanide, this is isocyanide. One a little bit more examples, if you like to, if you could have, like so one more important thing. This is our functional group isomer, but this cyanide and isocyanide, this is not our functional group isomer. Why? Why these are not the functional group isomers? Because it is the carbon chain is 1, 2, 3, 4, but here the carbon chain is not the carbon chain. Wait, this is not a functional group isomer, because again we don't have to take the carbon chain. But yes, yes, yes. Wait a second. How it could not be a functional group isomer? It could be a functional group isomer. So if we talk about cyanide and isocyanide, right? These are the functional isomer. I was taking another example. I was talking for another example. Like if you have this CN and if you have this NC, these are not the functional isomer because 1, 2, 3, 4 carbon, 5 carbon here. In first case, 5 carbon. In second is 1, 2, 3, 4, 5, 6 carbon. So obviously molecular formula is different. So they could not be put into the category of isomers. Next is we have one more type of ethylene. We have CH and CH2, then O, then CH3, then CH2 double bond CH and CH2 OH. So these are also the functional group isomers. This is the cyclic ether. We are taking the most important concept, means more commonly used concept, which could be talked as the isomers and which can't be taken as the isomer. And this is in all. Okay, so these are obviously not in the category of isocyanide and cyanide, but we are taking some more examples to just clarify what could be the isomer function group isomer. Next we have thiol and thioether, CH3 and CH2 and CH2SH, then CH3S, CH2 and CH3. This is thiol and this is thioether. Okay, if we pull out the oxygen and put the sulfur, then this is called as a thio compound. Okay, next we have nitro and nitrite. So this is nitro CH3 and double bond O, then O. This is called nitro and CH3O and double bond O. This is called nitrite. Okay, so these are again the category. Next we have enol and ketone. Again the enol and ketone. So enol is a double bond and OH. Both together are en plus all, enol. So CH2 double bond CH, CH2OH. This is in and enol and ketone CH3 C double bond O, CH3. Both have molecular formula C3H6O. One more we can take a cyclic enol and cyclic ketone. This is a C4H6O. Okay, this is the function of isomer. Now one more we could have amide and ether. Like one special type of example, if you could see, these are the very special type of examples we are writing. NH, this could be N double bond NH. This is actually ester plus 2 degree amine, and this is amide, and this is ether. So we are talking about the major type of isomers, but certainly there are isomers which are not fall into this category. That could also be the function of isomers. So you have to keep in mind that there could be more than one. Apart from these examples, there could be other examples of isomers also. You have to keep in mind also. Okay, so every time you have to look the particular question, what is the demand of the particular question, then you may tell that it could be the function group isomers. Means it depends on question that whether all the isomers we are writing till the H are fall into this category or not. Like let's say diene and alkyne. Diene CH2 double bond CH and CH double bond CH2. This is diene and alkyne is CH and double bond CH2 then CH3. Next is this is and 1 2 3 4 5 6 7 1 2 3 4 5 6 7. So this is diene and this is alkyne. So let me ask you a question. If I write this compound and this compound, is this which type of isomer is this? Certainly it is not a position isomer. Certainly it is not a function group isomer. Position isomer could be. I mean to say that it is not a function group isomer because both are cyclic ether. Okay, both are cyclic ether, but the position of ethyl, the main chain is not the same. Main chain is also same. 1 2 3 4 1 2 3 4. So this is a position isomer. So this is a position isomer. How it could be a position isomer? It is a position isomer because the position of the functional group is changing. It is in the initially 1 4 position. The cyclic ether will give the position like 1 4, and in the second it is 1 3 position. The cyclic ether naming we have seen already in the nomenclature. So that naming is changing of cyclic ether. So that's why it is a position isomer. Next, we are moving towards metamers. Metamers occur only in a multivalent function group. Multivalent function group could be like we have lots of function group. Let's see which are multivalent function group and which is not. So let's say fluorine, chlorine, bromine, iodine, alcohol, nitro. These are the monovalent function group. These are only one valency. So these are not multivalent function group. So what is a multivalent function group? We have ether, we have ester, we have ketone, we have amide, we have multi 3 degree 2 degree amines, we have thioether. So these all are multivalent functional group. So yes, these all are multivalent functional group. So in these multivalent functional group, if the molecular formula is same, then the position of the carbon before and after the multivalent functional group could be changed. Let's look the example what I am trying to say. Let's say you have CH3 and CH2O, CH2 and CH3, and CH3O and CH2 and CH2 and CH3. So these both are having a different function group. These are same function group. And what is the change? The change is this is the multivalent function group. Here two carbon, here one carbon and three carbon. Molecular formula is also same. So these type of compound are called as metamers. These type of compound are called as metamers. Okay. So let's look more examples of metamers. We are going to see a lot of examples of metamers, like HC double bond O and CH2 CH3. This is our ester, and similarly in ester, if you bring a carbon before, that is also a metamer. Metamers. Now let's take the more example. Let's take a more example: CH3 CH2 and then CH2 then CH3 and CH3 and H, CH2 and CH2 and CH3. So nitrogen has a different length of carbon chain in its different in bivalency. That is also a metamer. Okay. Uh, this this is also metamer with if you have this compound. Okay, you don't need to know the name. It could be hypothetical compounds also. Not every compound variety in organic, especially in GOC or nomenclature, may exist or not. Means by concept it may exist, but we certainly can't be sure that if there is any type of compound exist on the earth. Okay, so this is also a metamer. And if I write this in anhydride, one side we have cyclic phenyl ring, and one side we have a simple cyclohexane. So this is what is the relation between them? These are identical. These are same because in ester there is a difference between this carbon and oxygen directly connected to these two, but here carbon is directly connected to the phenyl group and oxygen is directly connected to the cyclohexane. So the position differ, both the position differ, but in non-symmetric, we can say it is non-symmetric, but anhydride is actually symmetric, so both side doesn't change. Doesn't matter that if we have different group on the different side, but the length if change, then it is also called the metamers. Okay, like if we write the compound like SC double bond O, then we have one more compound like this SC double bond O. So this is also a metamer. This is metamer. So we let's take some more examples of metamers. CH3 C double bond O H O C double bond O CH3 CH3 C double bond C double bond O CH3, then H, then H. Okay, so that is actually a same compound, but if we rotate, what is the relation between them? The relation between them is these are the metamer. Okay, these two are metamers because this compound and this compound has revert. Okay, these both are position has been reverted. So this is the metamer. Okay, and let's take some more example of metamer. Okay, metamer is quite important. Means it is less frequently used. So people forget about some example. This and HC double bond O, then C double bond O, then CH3 and CH2. This is also metamer. These two also are metamers. And if we take some more examples of metamer, we have that nitrogen and this is also metamers. So these all one about the metamers. So let's take one more type of compound which is known as our ring chain isomer. One more type of isomer that is called the ring chain isomer. Fifth type of isomer, ring chain isomers. So what are the ring chain? One compound is ring, another should be a chain. This is like C4H8, and we have one more and C4H8. In a degree of unsaturation, both have 1. Means the compound should have the same degree of unsaturation. Okay, means one necessary to be ring and one necessary to be chain, like this compound and this compound. Okay, so if I am gonna take some examples of which type of isomers are there, so we are going to do some questions. So I'll suggest you write the relation between them. Write the relation between compounds. What are the relations you can see? First you pause the video and try to answer by own. Like first compound, means you could also go with me. What is this? This is actually homologous series. Homologous series means a compound that differ by CH3 group. CH3 group by differ, that is known as homologous series. Okay. Second, which type of isomer it is? Tell me. This is chain isomers. Third, this is functional group isomer. Okay, because this is alkene, diene and alkyne. I hope you remember everything properly. Okay. Fourth, this is alcohol and this is ether, but the molecular formula is same. So this functional group isomer. Fifth, this is alcohol. This is also functional group isomer. Sixth, this is alcohol and this is also alcohol. This is position isomer. Position of the double bond are changing. Seventh, we have this is alcohol and this is we have double bond has changed, and so this is actually a functional group isomer. This is ketoenol isomer. Okay. 7. Then we have, let's take some more example. 8th, C double bond NH, then CH3. Then we could write the example NH, C double bond O, and then CH2, then CH3. Tell me which type of isomer it is. Amide. Both are amide. The position is changing. The molecular formula is same. The number of carbon you can check. Total number of carbon is same. So these are the metamers. These are the metamers. Okay, 9th. This one and this one. This is a functional group isomer. And 10th, this one and this one. These are alcohol. These are non-identical. Non-identical is also an option. So that was all about our structural isomer. Metamers, tautomers also is there. Tautomers will also cover, but these are the major isomers. Tautomers are generally covered later in the isomers part. Okay, we will cover that.